First, there is the absolute baseline of modern field artillery, the high explosive shell, and more specifically, the M107. It was developed by the United States shortly after World War II, evolving to become the primary high explosive round during the Cold War. It's about 43 kilograms in weight and is made with a steel body that contains around 7 kilograms of TNT or Composition B explosives. But the coolest part is just how simple it is. An artillery piece fires in on a ballistic arc, and upon impact, a point-detonating fuse triggers the payload. The explosion shatters the steel casing, sending thousands of jagged supersonic fragments tearing through soft targets and unarmored vehicles. It matters because it established a logistical and operational standard across the Western world. For decades, when a commander called for standard fire support, the M107 is what rained down. It's cheap to produce, highly reliable, and devastating in its simplicity, remaining in stockpiles worldwide to this day. It was later upgraded to the M795, and the Soviets would not be outdone with the 30F-45. Now, while the high explosive shells defined the 20th century, the next shell is one of the most brutal ever designed. Now, most artillery is designed to hit miles away, but when the enemy is right on top of you, you need the world's biggest shotgun shell, and this is where the canister shell comes from. Specifically, the modern M1028, fired from the 120mm smoothbore gun of an M1A2 Abrams tank. It is technically a tank shell, but it operates on one of the oldest artillery principles ever. There's no explosion midair or even a delayed fuse. Once it's fired, it expands and creates a cone of 1,000 tungsten balls traveling at around 1,400 meters per second. It basically shreds anything it's aimed at, including tanks and infantry. The M1028 is the perfect round to get enemies to back off a bit, and to make them think twice before launching an attack. But while canister is great for streets, fighting in a dense jungle required a much more sinister invention. During the Vietnam War, a new unconventional threat was introduced to the battlefield. Enemies were hiding in thick foliage that made them almost invincible, and this required something more specialized than a standard explosive. Enter the M546 anti-personnel tracer, widely known as the beehive round. It was fired from a 105mm field howitzer, but the shell was designed for lethality. Instead of explosive shrapnel or spherical tungsten balls, a single beehive shell is packed with exactly 8,000 tiny razor-sharp steel darts called flechettes. When a base is attacked, the artillery crew would point the howitzer and set the delayed fuse to detonate just about the tree line they were coming from. The case then blasts open mid-air, launching all those darts directly at the incoming troops. The unique shape meant they sliced through foliage to hit their target, but the insane thing is how they got their name. When these darts are unleashed, they make a similar sound to bees around a beehive. They were just a little more deadly. But sometimes shrapnel is still the best way to create a lot of damage. Invented by British artillery officer Henry Shrapnel in the late 18th century, the shrapnel shell reached its peak during World War I. It was fired by the British 18-rounder field gun, but unlike a high-explosive shell that relies on a shattering outer casing, a true shrapnel shell is essentially a flying shotgun. The casing is relatively thin and filled with hundreds of spherical lead or steel balls suspended in resin. A time fuse at the nose is set before the gunner fires. The goal is not to hit the ground, but to detonate directly above the enemy trenches. When the bursting charge ignites mid-air, it destroys the shell casing. It blows the nose off and blasts the payload of metal balls toward and downward in a lethal cone. It is historically vital because it defined the defensive nature of World War I and forced troops to dig deep into the earth to survive the relentless downward-striking iron rain. But the craziest part is that this shell is the predecessor to one of the most dangerous weapons ever created. The brutal concept of early shrapnel evolved during the Cold War, resulting in the dual-purpose improved conventional munition, or for short, DPICM, or cluster shells. When the Allies were faced with the threat of massive Soviet tank formations rolling across the Fulda Gap, they needed a way to destroy armor and lines of infantry at the same time. And this led to the M483A1. Unlike other artillery, it doesn't contain a single massive explosive payload. Instead, a timed fuse triggers a small charge mid-air. This strips away the base of the shell, unleashing 88 individual grenade-like submunitions. These bomblets are stabilized by tiny ribbon parachutes, ensuring they fall vertically. They are dual purpose because each bomblet contains a shaped charge capable of punching through 5 centimeters of steel armor. The DPICM basically revolutionized artillery lethality, turning a single howitzer into an area denial weapon. Unfortunately, the high dud rate left unexploded ordnance on the battlefield, and it is still controversial in modern military ethics. Now, if you think scattering dozens of unguided bomblets creates unexploded hazards, the Germans created something with insane precision. To hunt tanks efficiently without the collateral mess, German engineering produced the Smart 155. It stands for sensor-fused munition for the artillery. This shell operates on the cutting edge of battlefield technology. Like a cluster shell, it acts as a carrier, but instead of 88 dumb grenades, it ejects exactly 2 highly advanced submunitions. Once deployed over a target area, these submissions drift down on specialized parachutes that cause them to spiral. As they descend, onboard infrared sensors and millimeter wave radar aggressively scan the ground below. It looks for the specific thermal and physical signatures of armored vehicles. Once a tank is recognized, the submunition instantly fires an explosively formed penetrator, or EFP, which is a slug of molten tantalum, straight down into the thin roof armor of the vehicle. It is a true fire-and-forget weapon and can hit a target up to 37 kilometers away. Now, this munition is great for hunting tanks, but sometimes you need to hit a specific bunker or sniper in a dense urban environment. This requirement gave us the M982X caliber. It is another unique weapon designed by the United States, but this time the US made it GPS-guided and significantly extended the range. Once fired, small titanium canard fins deploy from the nose of the shell. Using an onboard navigation system combined with a hardened GPS receiver, the shell actively steers itself during the descent and glides toward a pre-programmed coordinate. But the cool part is the base bleed system. Basically, it has a small gas generator at the back that fills the aerodynamic vacuum behind the shell and gives it a range of more than 40 kilometers. The reason it's so valuable is that it brings sniper-like accuracy to heavy artillery. It has a circular error probability of fewer than 2 meters. This means it will reliably hit within 2 meters of its target. This extreme precision radically reduces the risk of collateral damage, allowing commanders to call in 155mm fire support incredibly close to friendly troops or civilian infrastructure. But with GPS jammers on the battlefield, the Soviets had to come up with something that basically sidestepped that. And this gave the world the 2K25 Krasnopol. It's a 152mm laser-guided shell. But here's the crazy part. The Krasnopol doesn't fly to map coordinates, it literally rides a beam of light, but also requires a forward observer, which is usually a special force team or a drone equipped with a target designator. This is to paint the enemy target. As the shell reaches the apex of its trajectory, its optical seeker powers on. They search for the specific pulse of that laser and use control surfaces to steer directly into the reflection. This is a crazy benefit because it can actually hit moving targets as long as the laser operator can keep the beam steady. This shell remains highly relevant. It's used by Russian forces in conjunction with Orlan-10 drones, and just to add even more fuel to the fire, it has an active firing range of over 24 kilometers. Now, whether a shell is dumb or smart, its reach is ultimately limited by the physics of drag and gravity. And to shatter those limitations, Rheinmetall Dental Munitions in South Africa engineered the M2000 Assegai VLAP. It stands for Velocity Enhanced Long Range Artillery Projectile. While most extended range shells use either a base bleed system to reduce drag or a rocket motor to actively push the shell forward, the VLAP combines both into a single, highly engineered projectile. Upon firing, the base bleed ignites first, smoothing the airflow and minimizing drag as the shell clears the atmosphere. Once it reaches the peak of its ballistic arc, a solid propellant rocket motor ignites. This thrusts the shell further downrange, dropping 4.5 kilograms of explosives. When fired from a .52 caliber barrel, the VLAP can reach targets over 75 kilometers away. This allows an artillery battery to strike deep into enemy territory, disrupting logistics and command centers. It is the ultimate weapon to safely sit in your base and hit the enemy. But not all artillery is meant to destroy structures. Sometimes it's meant to blind the enemy or clear them from entrenched positions. The M110 white phosphorus shell is known by almost all generations as Willie Pete and is a terrifying and banned weapon. The shell is packed with 7 kilograms of white phosphorus felt. When the bursting charge detonates, it scatters these wedges over a wide radius. But here's the scary part. Since white phosphorus likes to catch fire, the moment it comes into contact with oxygen, it ignites and burns at 2,800 degrees Celsius. It produces a thick cloud of white smoke that absorbs infrared signatures, completely blinding both the naked eye and thermal imaging cameras. In terms of its smoke effect, nothing works better to hide troop movements, but the incendiary nature makes it highly controversial. The burning chemical sticks to clothing and skin. It cannot be extinguished by water, making its use in areas populated by civilians a severe violation of international combat protocols. Once fired, it has a range of up to 30 kilometers, but a completely different shell is used to illuminate the night. The M485 is a 155mm illumination shell, commonly referred to as a star shell. It is a cargo round, but instead of sub-munitions, it carries a magnesium flare attached to a parachute. The artillery crew sets a mechanical time fuse calculated to detonate the shell approximately 600 meters directly above the target area. The base blows off, the parachute deploys, and the magnesium ignites. For roughly 120 seconds, the flare descends slowly, burning with an intensity of 1 million candle power. If strikes are needed over a pitch-black area, this is usually the weapon of choice. The M485 matters because it removes the tactical advantage of stealth. With the invention of night vision goggles, it might have diminished its use a little. But even today, it remains a vital psychological and tactical tool to expose enemy movement and direct conventional fire support in the dark. Stripping away darkness, though, does reveal the enemy, but slowing down a sudden armored assault sometimes requires the modification of the terrain itself. Enter the RAMS, or Remote Anti-Armor Mine System. The R718 shell does not explode on impact. It is another specialized carrier shell designed to literally create a minefield. Once it reaches the target coordinates, the shell expels 9 individual anti-tank mines and scatters them across a specific radius. These are magnetic influence mines, which means they do not need to be physically run over by a tank track. If the massive steel hull of an armored vehicle simply passes over them, the magnetic disruption triggers a shaped charge that blasts upward through the vehicle's belly. One of the reasons it's such a solid weapon is that it allows commanders to close off roads, bridgeheads, and flanking routes for kilometers. To prevent permanently denying the terrain to friendly forces, the mines are equipped with factory-set self-destruct timers, ensuring the battlefield eventually clears itself. While field artillery shapes the land battle with specialized payloads, we cannot complete this video without looking at the apex predator of the sea. The Mark 8 is the primary armor-piercing shell utilized by the massive 16-inch guns of the United States Iowa-class battleships. Unlike a 45-kilogram 155mm shell, the Mark 8 weighs 1,225 kilograms. That's roughly the weight of a compact car. It is a kinetic and explosive hybrid, designed specifically to engage heavily armored enemy warships, and each shell features a hardened steel cap, which bites into steel armor plating. It can punch through the armor of most vessels. Only after penetrating deep into the armor of an enemy ship does its 18-kilogram explosive bursting charge detonate. Fired from World War II all the way through Operation Desert Storm, the Mark 8 represents the absolute pinnacle of brute force ballistics. It required massive propellant charges to fire, but it remained accurate enough to lob a ton of steel over 32 kilometers, leaving craters the size of swimming pools. But here's the thing about war. Sometimes you just need a solid rifle. So check out this video and see every type of rifle explained, and I'll see you in the next one.